Good morning, secondary 1. Today we are going to make a revision to refresh your information, so please pay attention. These are very important questions. Question number 1. Which of the following express a quantitative measurement? When he asks you about quantitative measurement, so he needs a number here. Number A, aluminum bar is longer than the copper bar, and this is not include the quantitative. Okay, number 2, the first solution is more concentrated than the second solution. Also, this is not a quantitative measurement. Number C, the color of the first solution is blue. No. So the answer here will be number D. The temperature of the second solution equal 60 Celsius degree, and this is quantitative measurement. This is quantitative measurement. The quantitative measurement must include a numerical value and measuring unit. Numerical value and measuring unit. So the answer here will be number D. Number 2. Which of the following is an application of Avogadro's postulate? Pay attention. Avogadro's postulate. Number A, oxygen atom is 16 times heavier than the hydrogen atom. No. Number B, 1 cubic centimeter of each argon and oxygen and ammonia gases contains the same number of molecules at 80 Kelvin and 1 atmospheric pressure. This is the right answer. The Avogadro postulate talks about that 1 mole or equal volume of different gases have the same number of molecules. Equal volume of different gases have the same number of molecules. So the answer here will number B. Letter B, okay? Number C, a mole of any gas such as methane contains 22.4 liter. This is Avogadro law. Number D, volume of hydrogen gas increases by increasing its number of moles at constant temperature and pressure. This is talking about the Avogadro law, not Avogadro postulate. Pay attention. Number C, talking about the Avogadro law, that we use it in solving the problem only. Okay, so when he asks you about the Avogadro law definition, it will be number D, the volume of hydrogen gas increase by increasing its number of moles at constant temperature and pressure. Okay, this is directly proportional between the number of moles and the volume of gas, and this is the Avogadro law. Let's go to see the next question. What is the number of moles of hydrogen sulfide in 49.7 gram sample of it? And he gives you some choices. So here you must know the chemical formula of hydrogen sulfide firstly, and the chemical formula of hydrogen sulfide is H2S. And he gives you the molar mass of S equal 32 and of hydrogen equal 1. What is the number of moles of hydrogen sulfide in 49.7? Firstly, I will calculate the number of moles. Yes, here I have 1 mole of hydrogen sulfide contains 34 grams. This is the molar mass of hydrogen sulfide. 2, as we have 2 hydrogen atoms plus 32, the molar mass of sulfur, so the result will be 34. So 1 mole of hydrogen sulfide contains 34 grams. What about 49.7 grams? Contains how many moles? So I will put a question mark under mole. That in 49.7. What is the next step? Yes, cross multiplication. So the number of moles will be 1.46 moles. So the answer, number B, 1.46 moles. Okay, the next question, number 4. Which of the following acid is a strong acid? HF, this is hydrofluoride, and this is a weak acid. KOH, this is potassium hydroxide, and this is base. HClO4, and this is perchloric acid, and this is a strong acid. Strong acid. So the answer here will be HClO4. He said in your curriculum that perchloric acid is a strong acid. Okay, pay attention. Can you remember the strong acids? We have many types of strong acids. We have HClO4, perchloric acid. We have sulfuric acid, H2SO4. We have HNO3, which is nitric acid. HI, which is hydroiodic acid. HB, which is hydrobromide acid. Okay, all of these are strong acids. Let's go to see the next question. Number 5, on dissolving 16.4 gram of hydrofluoride in water, HF in water, a solution, its volume is 2 multiplied 10 power 2 milli, and its concentration is spaces formed. Now he asks you about the molarity. As he gives you the volume, so he asks you about the molarity. If I have the volume, I can calculate the concentration by using the molarity. And he gives you the molar mass of hydrogen equal 1 and fluorine equal 90. Let's go to know the steps to solve this problem. Number 1, you must write your rules in the correct way. Molarity equal number of moles of solute divided by the volume of solution, and pay attention, the volume of solution here must be in liter. Now I don't have the number of moles of solute, but I have the mass of solute, which is hydrogen fluoride. The mass of solute equals 16.4, so I can calculate the number of moles by divided mass divided by molar mass, which is 20. 19 plus 1 equal 20. So the number of moles equals 16.4 divided 20. What's about 20? 20 is the molar mass of hydrogen fluoride, 1 plus 19. Okay, so the result will be 0.82 moles. This is the number of moles of solute. Now I can calculate the molarity, easy. The molarity equals 0.82 divided by the volume of solution, which is 2 multiply 10 power 2 milliliter, and here I changed it into liters, which is 0.2 liters. Okay, how can I change 2 multiply 10 power 2 by divided this value divided by 1000? I can get the result in liter. Now I can calculate the molarity. Molarity equals 0.82, the number of moles, divided by 0.2, the volume after changing into liter, and the answer will be 4.1 molarity. So the answer here, letter D. Okay, number 6. What is the type of compound which dissolves in water and doesn't dissolve in benzene? Pay attention, water is a polar solvent, and the polar solvent dissolves the polar compound and ionic compound, while benzene is a non-polar solvent. Non-polar solvent dissolve non-polar compound only. This is about the statement which said like dissolves like. Like dissolves like means the polar solvent dissolves polar compound, and non-polar solvent dissolves non-polar compound. Here I have water is a polar solvent which can dissolve polar compound or ionic compound. So the answer will, yes, letter D. Number 7, the separating funnel. As you see in the figure, this is the separating funnel. Pay attention, we use a separating funnel to separate the suspension only. the heterogeneous mixture that I can distinguish between its component by our naked eye. So here the choice must be suspension. Okay, the separating funnel is used to separate the components of space mixture. Number A, cobalt 2 chloride in water. Cobalt 2 chloride in water, this is the solution, as cobalt 2 chloride dissolves in water. Number B, aqueous solution of cobalt 2 chloride and benzene. Yes, this is the right answer, as cobalt 2 chloride doesn't dissolve in benzene. Okay, so this is a suspension and I can separate it by separating funnel. For sure I can't separate milk by using a separating funnel, or can't separate copper sulfate in water, as copper sulfate dissolves in water. So this is a solution and I can't separate it by using separating funnel. Yes, the answer here will be letter B. Okay. Number 8. Which of the following choices express the dimension of two-dimensional nanosubstances? Pay attention. To choose a nanosubstance which contains 10 power, so the power must be -9 or smaller than -9. Okay, here in letter A, 1.2 multiply 10 power -11. Yes, this is a nano substance. 200 multiply 10 power -10. This is also nano. 320 multiply 10 power -12. This is also nano. So number A contains or has three-dimensional nano substance, as the length is nano, width is nano, and height is nano. So A is the wrong answer. Let's go to C. B. What about B? 21 multiply 10 power -10. This is nano. 0.18 multiply 10 power -5. This is greater than -9, so this is not nano dimension here. 17.9 multiply 10 power -9. This is also nano. So the answer here will be letter B, as it contains length and height nano dimensional, while width not nano dimension. Okay, so letter B contains two-dimensional nano substance which are length and height. Okay, number 9. The formula of antimony oxide is Sb2O3. So you can conclude from this formula that the chemical formula of antimony is Sb. And the valency of oxygen is 2. And the valency of antimony is 3. Okay? And that of sodium phosphate is Na3PO4. We know that Na, the valency of Na is 1, and the valency of PO4, which is atomic group, is 3. What is the formula of antimony phosphate? Okay, from this information, you can conclude that the chemical formula of antimony is Sb, and its valency is 3. And the chemical formula of phosphate is PO4, and its valency is 3. Yes, we can cancel the valency of these two substances together, as they have the same valencies. So we can cancel the valency here. So the chemical formula will be SbPO4, which is letter A. Okay. Okay, let's go to see the next question. Number 10. The number of atoms in half a mole of formaldehyde HCHO equals. Okay, pay attention. This is a very important question. We know that the number of atoms is the number of particles, and we know the law of Avogadro law. Avogadro law said that the number of particles equal the number of moles multiply Avogadro number. So here the answer may be half multiply Avogadro number, but really this is a wrong answer. So please pay attention. If he asks you about number of atoms only, so you must count how many atoms in this compound. How many atoms in formaldehyde? HCHO. So here we have 4 atoms in 1 mole. So 1 mole contains 4 multiply Avogadro number. 4 multiply Avogadro number. But here he asks you about half mole. So the half mole contains 2 multiply Avogadro's number. 2 multiply Avogadro's number. Pay attention. This is only when he asks you about the number of atoms. If he asks you about the number of molecules, so you calculate it by multiplying number of moles multiply Avogadro number as we calculated. Okay? But when he asks you about the number of atoms, we must count how many atoms here. Here I have 4 atoms, HO, 4 atoms in 1 mole. So 1 mole contains 4 multiply Avogadro's number. What about half mole? Half mole contains 2 multiply Avogadro's number. This is very important question, so please pay attention. But if he asks you about the number of molecules, we calculate it by normal way. Calculate the number of moles. If he asks you about the number of molecules of, for example, 1 mole, so we will multiply 1 mole multiplying Avogadro's number as the normal way. Okay? But here the answer would be number C, 2 multiply Avogadro's number. Number 11, 20 milli of carbon monoxide gas combust in excess of oxygen according to the equation. What is the produced volume of carbon dioxide gas? Here I have 2 moles of carbon monoxide producing 2 moles of carbon dioxide. Pay attention. He asks you or he talks about carbon monoxide and carbon dioxide. So I will write both of them, carbon monoxide and carbon dioxide. 2 moles of carbon monoxide from the equation producing 2 moles of carbon dioxide. So what about 20 milli of carbon monoxide? It will produce 20 milli of carbon dioxide. It's so easy by making crossing multiplication. Okay, let's go to the next question. In the reaction Ca3PO4 by 2, this is calcium phosphate plus sulfuric acid producing calcium sulfate plus phosphoric acid. Okay, pay attention again. Calcium phosphate plus sulfuric acid producing calcium sulfate plus phosphoric acid. 120 gram of calcium phosphate was added to 4.4 gram of sulfuric acid. Illustrate by chemical calculation the limiting reactant for this reaction. Pay attention. The limiting reactant we can calculate the limiting reactant, or we can know the limiting reactant by producing a lower amount of products. But here we must calculate the number of moles only. Okay? Number 1, I must calculate the number of moles of calcium phosphate. The number of moles of calcium phosphate, as we know that the number of moles equal mass divided by molar mass. So the mass of calcium phosphate is 129 divided by the molar mass of calcium phosphate is 310. So the answer will be 0.416 moles. Then calculate the number of moles of sulfuric acid. The mass of sulfuric acid here is 4.4 divided by its molar mass 98, so the number of moles here will be 0.044. Now I will choose one product only. One product only. The products here, calcium sulfate and phosphoric acid. Calcium sulfate and phosphoric acid. Here I choose calcium sulfate. Here I choose calcium sulfate. So I will take one reactant with calcium sulfate and the other reactant with calcium sulfate to know which one is limiting reactant. Okay, number 1, Ca3PO4 by 2, this is calcium phosphate and calcium sulfate. Here 1 mole of calcium phosphate producing 3 moles of calcium sulfate. In the other side, yes, I will choose the other reactant with the same product, please. Please, with the same product. 3. I put 3 as in a chemical equation. 3 moles of sulfuric acid producing 3 moles of calcium sulfate. Calcium sulfate. Here, 1 mole of calcium phosphate producing 3 moles of calcium sulfate and 3 moles of sulfuric acid producing 3 moles of calcium sulfate. Okay, I will use the moles that he gives me, the moles of calcium phosphate that I calculated it before in the previous step is 0.460. Yes, produce how many moles of calcium sulfate? In the other side, I will use the moles of sulfuric acid that I calculated it before, which is 0.044 moles, producing how many moles of calcium sulfate? Cross multiplication. In the first one, producing 1.248 moles. In the second one, producing 0.044 moles. And we said that the limiting reactant appearing in producing smaller amount of moles in products. So the limiting reactant here is, yes, sulfuric acid. The limiting reactant here is sulfuric acid. This is my answer. He asks you about the limiting reactant only. But sometimes he asks you about the excess reactant and the extra amount of excess reactant that doesn't react in a chemical reaction. Pay attention. The limiting reactant here is a sulfuric acid. Once the sulfuric acid is consumed, the reaction will stop. And the other reactant here, which is calcium phosphate, considered as excess reactant, extra reactant. Sometimes he asks you about the extra reactant of the excess reactant that doesn't react in the chemical reaction. So let's go to see how can I calculate the extra amount of excess reactant. To calculate the extra amount of excess reactant, here I will calculate I will compare between the two reactants only. Here I don't write the product. Here I will compare between the two reactants. The two reactants here, calcium phosphate and sulfuric acid. From the chemical equation that he gives it to you, 1 mole of calcium phosphate needs 3 moles of sulfuric acid. 1 mole of calcium phosphate needs 3 moles of sulfuric acid. Here, sulfuric acid is a limiting reactant by which the chemical reaction has finished, yes, by consumed the amount of sulfuric acid. What is the amount of sulfuric acid that I have here? Yes, I have 0.044 moles of sulfuric acid as I calculated it before. Okay, so I will put the number of moles that I have from the sulfuric acid, which is 0.044 moles. How many moles reacts with 0.44 moles from calcium phosphate here? Yes, by crossing multiplication. So the number of moles of calcium phosphate that react with 0.044 moles is 0.014 moles. So here, pay attention. I need only 0.014 moles from calcium phosphate. How can I calculate the extra amount of this is the excess reactant, calcium phosphate considered as excess reactant. I need only 0.014 moles. But he gives you how many moles of calcium phosphate? He gives you 0.416 moles. So by subtract 0.416 moles minus 0.014 moles, I can calculate the extra amount of excess reactant that doesn't enter in a chemical reaction. Here the extra amount equal 0.416 moles. This is the number of moles that he gives you before from calcium phosphate minus 0.014 moles that I need to react with 0.044 moles only, and the excess amount here or extra amount here that doesn't enter in a chemical reaction of excess reactant is 402 moles from calcium phosphate. Okay, I hope you to understand this problem. This is a very important problem. I hope you all successful in your exam, so please pay attention and study hard. Thank you and goodbye.